All right, Julia, I wanted to make a video of the assignment on piecewise functions that you wanted me to go over. I thought maybe this way you would be able to watch it when you had time and felt ready to do it and to be able to remember it. Also, so that you could pause it, and write your own notes if you wanted to. So going through, we'll just go through question by question. So this first one, it wants us to evaluate the function for the indicated values of x. So you would solve each of these individually, finding which domain value that x value fit. So we're looking for a domain value that -10 would fit into. And so we're going to use the 2x plus 1 because x is less than or equal to -5. -10 would fit there. Plugging -10 in for x and solving, we get -19. Okay, doing the same for 2, we would use f of x equals x squared because 2 is less than 5, and so it fits within that range. Solving for x, we would get the answer 4. Okay, substituting -5 in, we're going to use the first equation because -5 fits this domain value where it's x is less than or equal to -5, so it fits here exactly. And solving, we would get -9 as our answer. Okay, f of -1, we're going to use the second one because that's where -1 fits within that domain value. And solving, we get 1. Okay, and then the last one, f of 8, it fits into the last function, so 3 minus x, because 8 is greater than or equal to 5, right? And so solving it, we get -5 for our answer. All right, so you're just substituting them in the correct function rule that it fits, okay? All right, for the next one, we're looking for which rule describes the function whose graph is shown. So we're going to look at the parameters. And for this one, I first looked at my range of values here. So we have looking at the domain values that fit the graph. And so we found that it's either one of these two spots because it goes from 0 to 4, right? And so we know that x is, so for this leg, okay, x is less than -2, so starting here, x is less than -2. -2, x is between -2 and 2, so -2 and 2, that fits there. And then for the third function, we have x is greater than or equal to 2, so that fits there. Okay, and so then we're choosing between these two. We've ruled out the first answer choice. And so then all we do is choose a value that fits within one of these functions. So I chose -3. So when I plug in -3 into the function, I should get -3 plus 6 gives me 3. So at -3, it should be 3. It crosses the line, so that does work. And so that's how I would know. Otherwise, this one, I would check -3 here, and -3 plus 4 would be 1. Our line would need to be here, and it's not. So that's what makes g of x the correct choice. I don't know if if I finished answering that. I'll have to go back and look. I can send you the document as well when we're done. Okay, so looking at the domain for that graph, same graph, we know domain values are the x values. The arrows on either end indicate that it goes to infinity or negative infinity, and so that's how we knew that was this answer. On the range, we're looking at all possible y values or output values that the function can produce. And so our minimum, so the negative infinity, since it goes all the way out, it would go all the way down the y-axis, and so that would be negative infinity. But then we know that we have hard stops here at 4, and so 4 is our maximum. Okay. All right, so looking at this data, they have about state income tax. They want to know over which part of the domain is the piecewise function defined as f of x equals 0.05, so 5% x minus 300. And so we would know that it is for income levels 15,000, between 15,000 and 40,000, because the 0.05 is our 5% tax bracket. Okay, and it's only for values above 15,000, but for the next 25,000, which would be anything up to and including $40,000. Okay. And then we would plug it into the equation to figure out the amount of taxes owed on 32,000. Okay.
Hi, Mona. What's up?
All right, so in the next question, studying the functions below and then answering the questions that follow. So looking for the domain of f of x. So you would actually have to, or I would suggest that you graph the piecewise functions to see what the domain and the range fall into. And so I did that. I just, sketched an axis, and then using the information that they gave me, I created X and Y T-charts and just chose some numbers that fit into those domain values, and then I just created my quick little graph. And when I graph in pen, I always make a mistake, so I made a mistake there, but I whited it up for you. Okay, and you know that an open circle indicates that it is just less than, it is not including that value. And if you know on a function you can only have one y value for every x, and so that's why both of those need to be open. When it says it's greater than or equal to, moving beyond, then we would have a closed circle there for that one. Okay, so I did all of that, and once I graphed it, I have arrows looking at my x values for the domain. I have arrows going to negative infinity and infinity, and so on this one I have negative infinity to -2, and then this one starts -2 all the way to infinity. And so that's where we use our union symbol to combine the different intervals of the piecewise function. So it's negative infinity, -2, the union symbol, -2, infinity. Sorry, that cut off, but it looks like that. Okay, and then for the range, our minimum value is -4, and our top value, maximum value, is infinity. Okay. All right, so which values of x are points of discontinuity? So discontinuity are talking about the open circles, and so all three of these points are points of discontinuity. Now, the removable discontinuities are those that we could take out or fill in, right? If we were going to fill in the holes, we could come up with a function that is function rule just for that one spot. But since this -2 is included in that function rule, -2 is not an option for a removable discontinuity. And so therefore it's only the one at 0 and the one at 4. Okay. All right. Okay, so which values of x are points of discontinuity for this function? We're going to look for the same values of x in the different domain values. And so we're looking for that, and we find that 0 and 2 both fit that. Okay. All right, complete the definition of h of x so that it is continuous over its domain. So we're wanting to fill in that gap where we're missing that less than or equal to 0. So we need a value for x equal to 0. And so for that, we would just plug in 0 into that equation, and we would get 0, or you could do in the following function and do the square root of 0, which is 0. So we know a is x equal to 0. And to solve for b, when x equals 4, to fill in that missing piece there, we can plug 4 into either of these equations, and I did that showing that we would get 2 for either of those functions that we used, and so that's how a is 0 and b is 2. Okay, which statement is true for g of x? And so we know that we can eliminate this first answer choice. It says you can remove the discontinuity at x equals 0 by defining g of 0 as 0. Well, we can't do that because there's two options. There's a jump discontinuity here, and neither function includes 0. There is a hole or discontinuity here at 3, and so we could define g of 3 is equal to -1, and that would fill that spot. Okay. All right, so comparing and contrasting the following piecewise defined functions. So you're looking for similarities and differences here. And so looking at both of them, that they each have a linear portion, right? This first function here is a linear function. The x squared and x squared, those are quadratic portions. So each of them have a quadratic function in them. The y-intercepts of both linear pieces are the same at 2, and the quadratics both point upwards since the x squared is positive on both. But they have different y-intercepts, where one is at 1 and the other is at 2, so that's where they would differ. The linear portion of the first function is decreasing, while the linear portion of the second function is increasing. And so you would just select whichever ones of these you use to fit your response. Okay, solving real-world problems using the graph. And so this is just practice reading a graph and knowing the information and applying it. And so we use the graph to find the total cost of a group of 16 people. So you follow the line 16 all the way up and find that the price is consistent for groups above 15 people. So at $2,500, it turns out to be $156.25 per person. If we had a group of 10, follow this up. At 10, it looks like it would be $1,300 for a group of 10, or $130 per person. They're asking for the difference between the two, and so the difference is $26.25. Okay. All right. I did want to show what we used. Okay, what questions you missed on the quizzes. Okay, so for this one, it says which graph represents the following piecewise defined functions. So what we're looking for, when I look for these, I'm looking for the open and closed dots. So we have an open dot here at -2, 2. So I want to make sure that there's not an underline over here anywhere for -2. It should be open, and so it doesn't look like that fits. Okay, and so you selected this one, which shows a jump function here, which we don't have because we do have -2 part of two different functions, and our jump function is only over here at the 3. Okay, there to there. Okay, then the next one was this one. Okay, which rules define the function below? So it should be y equals x plus 2, y equals 5. And so, and the way that I solve these is I just choose a value on the line and I plug it in, and if it's that one, then it works, right? If it's true, if it works, then that is the option. Okay, so again, choosing which graph represents the piecewise defined function, and let's see which one you chose. This one, and it's this one. So the difference between these two is where we have this closed circle or open circle. So you switched those two there and over here. So when you're reading it, this one needs to be less than -2, but not equal to it. All right, so that first leg, there's no underline here, so that's why that first circle is open. And then for the next function, it's x is greater than or equal to -2, and that's why this one is closed. And then it goes to x is less than 1, and again, it's not underlined, so that's going to be an open circle. So this one should be open, and then the next one, it is greater than or equal to 1, so that's why the closed circle is on this one. Okay, so just paying attention to when we have that less than or equal to portion to know whether it's closed or open. Okay, that was the first attempt, and then here's the second attempt. And so this again is the same issue, just knowing when we have a closed or opened end. So that's the only thing you switched, was that part right there. Okay. All right, if you have any questions at all, please let me know. And then if you want to make a meeting to talk about anything, please feel free to do that as it fits your schedule.